Hi, so in today's video we're going to talk about segments, tangent, and secants to the circle. So it says that you need to be comfortable with these theorems regarding tangents and secants. And just remember, tangent touches the circle at one point and secant is going to intersect at, or touch at 2 points. Now, so number one says if a line is tangent to a circle, it is perpendicular to the radius drawn to the point of tangency. So that's right here. So OD in red there is my radius, and the line tangent BA to the circle, and the point of tangency is point D. So that is my point of tangency. So at that point, the relationship between the radius and the tangent line is going to be perpendicular, or forming that right angle. All right, so let's take a look at example number one. Example number one says that given tangent line BC, which we have here is 20, it says find x. Well, we can see that BO is a secant, and B to the point of the circle is 10. We're looking for x. In the yellow that I've highlighted there, we should recognize that that's a right triangle. And we have a missing side of the right triangle. So if we have a missing side of the right triangle, we know we can use the Pythagorean theorem. So we're going to do that. Well, let's set up. Side opposite my right angle is my hypotenuse, and I have the other two legs. So that's going to be, well, we know it's a squared plus b squared equals c squared. So we know it's going to be one leg is x squared, and that's going to be plus the other leg, which is 20 squared, and that's going to equal my hypotenuse. Well, the hypotenuse is going to be x plus 10, because you don't know what that is, that side. But you do know that that, again, is a radius, so I can call it x plus 10 squared. All right, well, the first thing I need to do is I need to find out what is x plus 10 squared. So I'm going to go over here, and I'm going to write x plus 10 times x plus 10. So I'm going to FOIL or distribute, and I'm going to get x squared plus 10x plus 10x plus 100. I'm going to combine like terms. I'm going to get x squared plus 20x plus 100. And I'm going to put that down. So here I'm going to have x squared plus 20 squared equals x squared plus 20x plus 100. I'm going to subtract x squared to both sides. And then I'm going to get, well, 20 squared is 400, so I'm going to have 400 equals, these cancel, 20x plus 100. I'm going to subtract 100 to both sides, and I'm going to get 300 equals 20x. Divide 20 to both sides, and x equals 15. And that's my answer. All right, number two. Number two says, tangents drawn to a circle from a common external point are congruent. And it says that you may think of this as the hat theorem because the diagram looks like a circle drawing a hat. And it's pretty, if you think about it, the hat that you have, if you have this type of hat, if you do, please don't wear it to class. But anyway, if you have that hat from C to A, is going to equal from C to B. So those two tangent lines from that point, or from this point, C, all right, it's going to be congruent to the circle. Again, please don't wear that hat to class. Anyway, example two. Example two says segments drawn on tangents, solve for x. Well, what I did in this problem is I just went around and I just filled in the different information that we have. We know we have a common point, and we know we have this line, or these two lines that are drawn tangent to the circle. So if this side is 4, then the other side must be 4. I know I have a common point here, and I have two tangent lines drawn to the circle. And I know if this side is 3, then this other side must be 3. And once again, love these different colors. Okay, that one is not cool. Will this one show up? Yeah, cool. All right, so I know if from this common point, I have 2 that's drawn, this tangent line, and the other side must also be 2. So x equals 5. That's 2 plus the 3. All right. So we have 2 more theorems. So the next one says if 2 secant segments are drawn to a circle from the same external point, the product of the length of one secant segment and its external part is equal to the product of the length of the other secant segment and its external part. Sorry, we had the train going. It's a little distracting. But anyway, so this is saying that this B line, all right, the whole amount, it's going to be times the A, the external. Let's get some colors here. So the full amount B times the external A is going to equal the full amount D times the external C. Now, there's another way of thinking of this, and I've seen this before, and it's called, and it is what I've pictured there. It's the, oh boy, don't do that. All right, so that was weird with the calculator. But anyway, so what it is, it's the outside times the whole equals the outside times the whole. So outside, and that's exactly what I have there. Outside times the whole segment equals the outside times the whole. So O times W equals, and that's the same thing that's over here, equals O times W. The next one says, if a secant segment and tangent segment are drawn to a circle from the same external point, the product of the length of the secant segment and its external point equals the square of the length of the tangent segment. That sounds like a lot, but it's not too bad. All right, so that's saying that I'm going to take A, that's A squared, that's that tangent line, that's squared, okay, and that's going to equal, well, the product of the whole amount times the outside amount. So I'm going to have, and if you think about it, it's kind of the same, except you're squaring that A piece. So that's going to be O times W again equals O times W. Well, that's going to be B times C if I'm substituting in. So you can look at this or think about this in a different way, and that's going to be A times A squared. All right, let's take a look at some examples. It says, exercise 3, given circle with 2 secants, find x. So I have my outside amount. The outside amount is 5. And my outside amount here is 6. My outside amount here, well, you should think that's going to be x plus 5. And then my outside amount here, or my whole amount, I'm sorry, my whole amount, I apologize, the green is the whole amount. Well, that's going to be, well, 6 times, I'm sorry, 10, the 6 plus the 4. So when I set this up, O times W equals O times W. So I'm going to have 5 outside amount times the whole amount, x plus 5. That's going to equal, well, my outside amount, again, the yellow, 6, times my whole amount, which is 10. 6 plus the 4. So I'm going to distribute. I'm going to have 5x plus 25 equals 60. I'm going to subtract 25. I'm going to have 5x equals 35. X equals 7. All right, example 4, kind of the same idea. So I'm going to have, where are my colors? Here we go. My outside amount, 6, that's a tangent line only there, so that's going to be like this example, or this theorem. And then I have my outside amount of x, and then I have my whole amount. But my whole amount is going to be x plus 5. So if I set up again, this is going to be x times x plus 5, and that's going to equal 6 squared. So I'm going to distribute. I'm going to get x squared plus 5x equals 36. All right, now I have a quadratic. So I'm going to set this equal to 0, this equation. So I'm going to subtract 36 to both sides. So I'm going to get x squared plus 5x minus 36 equals 0. Well, what I'm going to do is I'm going to factor this. Now, there are other ways you can, I teach an X method, completing the square, however you come up with the two factors. But I'm going to factor. I have x plus 9 and x minus 4. And that's going to be set equal to 0. All right, I'm going to set each one of those equal to 0 to solve, and I get x equals -9 and x equals 4. Well, I know I'm not going to, I can't deal with the negative because it's distance, so I know my answer is x equals 4. All right. So what I want you to do is apply what you've just learned to problems 1 and 2. Come into class with your questions, and we'll go over them next time. Go Cats, go Knights.